Hi, I'm Emmanuel, founder at Sept, and today I want to talk to you about Bazel for Python. So I don't have any stocks in Bazel. I don't really even care if you use it. I just want to give you my experience using it, how I found out about it, the good things about it, the things that are not so great, and how it can potentially help you. So that's why I'm saying how I learned to stop worrying, kind of, not really, and love Bazel, almost. And that's a reference to this movie down there, Doctor Strangelove. So just a couple of things about me. I'm French, as you may hear. Started my career in academia doing particle physics research at CERN, which is where I started using Python. And then I moved to the US, worked at Instacart for 4 years, did mostly Ruby and then some Python at the end when I got back into data science. And then for 4 years, I was I was tech lead of ML infrastructure at Cruise. So building all sorts of systems and infrastructure for ML teams to develop models faster and ship them to the car. And I left in 2022 to start my own company, Sept, which is an open source company that builds ML infrastructure. Happy to talk more about it later. So that's roughly about me. So what is the problem that we're talking about today? So I'm sure you all have a bunch of repos with maybe Python and other languages. And so your repos produce assets. So they produce wheels or binaries like maybe a web server or a Docker images and so on. So they build all those things. And so you use different methods, different functions, CLIs and scripts to build those assets. Some of your Python code may leverage some non-Python assets, so like static libraries like CUDA drivers. You may be using some C++ libraries through PyBind, for example, and you need to get all this synchronized. Like if you make a change in your C++ code, you need to build it, link it, and then use it in your Python code. So that's kind of pretty cumbersome. And then you may have multiple apps within the same code base, the same repo. So for example, you could have a web server, you could have a CLI, you could have an SDK in the same repo, maybe some analytics pipeline, some ML code, all of this in the same repo. And so testing all those different apps, you use different tools, maybe PyTest or unit test for Python, and then other scripts for other purposes. And so you need to keep track of, okay, what is the command line I'm using for this particular app? What is the command line I'm using for this other app? So that can be cumbersome at some point. And one of the problems that I've noticed when I was working at Cruise is that sometimes you have part of the code base that use a certain version of Pandas, for example, or NumPy, and then some other app across the repo that uses another version of NumPy that's not compatible with the other one. And so when you're trying to share some code across those apps, then you hit those issues, and you can spend weeks trying to figure out, okay, how do I upgrade NumPy in this other part of the repo without breaking anything? You have to get approval from a bunch of other teams, and it gets really, really tricky. So this is the kind of things that Bazel are trying to help with in the context of a monorepo. And so the last problem that we can talk about as well is that maybe your repo produces a library for others to use. And so you want to support multiple Python versions. So maybe you want your users to be able to use your library, your wheel with like 3.8, 3.9, 3.10, and so on. I'm not talking about Python 2. I don't think people are concerned about that anymore. But even just testing with multiple Python versions can be a challenge. And also, people have on their machine different versions of the Python interpreter, even for the same major version, like let's say 3.8. Some people may have 3.8.11, 3.8.13. Some people may be on a Linux machine, others on a macOS machine. And so having a consistent experience across all the dev boxes and the CI that's going to run your code and your production servers is a challenge, because you may have an issue in CI that you can't reproduce locally, or somebody has an issue with a test that breaks but doesn't break on your machine. So not having a consistent environment across all your the places where your code is going to run is a problem, is a time sink when you try to debug. So I'm talking about this in the context of mono repos. I mean, we can have discussions forever about whether monorepo or multi-repo is best. I first encountered monorepos when I worked at Cruise. At first, when I joined Cruise, there was one big repo, mostly C++ code for the car code, so the code that runs the cars that you see out on the streets. And then everything else, so internal tools, machine learning code, data science were all spread across dozens of repos. And when an engineer had the idea to migrate everything to the mono repo, I was like, I don't want to do that. The build time over there is about 30 minutes. I don't want to have to wait 30 minutes to see my own test fail or succeed. So I don't want that. I don't want to have to use all the tools that are prescribed to use in the mono repo. So at first I was against, and I got convinced that this actually was a good thing. So over the course of about 2 or 3 months, we started moving things into the mono repo, and thanks to tools like Bazel, it actually was a major productivity gain. So some of the reasons why it was much better is that, first of all, you reduce the dependency headaches because you just use the one version of pandas, numpy, or whatever else that is supported by the repo, and that is it. If you want to upgrade this, you have to make the case to the rest of the teams. We need to go to that version for reasons X, Y, Z, and then you need to make sure that the build team helps you migrate the repo. Of course, that's a big deal. For example, when you migrate PyTorch versions, that can be a lot of work. You need to align a lot of people. You need to do a lot of validation work. But overall, you don't have to worry about different versions of a package being used in different apps because the versions are kind of frozen across the entire repo. Another good thing about a mono repo is that at Cruise there was a build team. So I think probably 4 or 5 engineers that were build engineers. So their job was to make sure that the build was as fast as possible and that all developers had the tools that they needed. So if you're a Go developer or a TypeScript developer or a Python developer, that you had the tool chains to build your code and execute your tests. And so that means that when things break, you don't have to figure things out by yourself. You can submit a ticket to the build team and they help you out. If you're in your own repo that is not the mono repo, then you're on your own, which can be good sometimes, but it means that you don't have priority support from that team. And then another reason that was great, a good reason to use mono repo is that propagating changes across code base was much easier. If you have one repo per asset, so like per wheel, for example, if you want to make a change and see the impact in a downstream service, you need to make a change in your code, make sure that it passes the CI. You need to build your wheel, publish your wheel to like Artifactory or some other sort of artifact storage, and then you need to update the dependency in the other repo. Maybe make a branch because your wheel is not yet public, for example. And so that can take you maybe a couple days just to see the impact of one change. And if your change is incorrect, then you're kind of screwed. You have to do this all over again. So a very slow iteration loop because you have to propagate changes via public packages. When I say public, I mean public within the company. So when you work in a mono repo, you can make a change to any part of the code base and just go to the other app and just execute whatever you have to run, and your change will be taken into account. So for example, at Cruise, maybe somebody is writing an ML pipeline that leverages a C++ library for some geometry calculations, and so they can just make the change in the C++ code, and then they can call the Bazel targets to run the Python test. The Bazel target will detect that there was a change in the C++ code somewhere, will build the C++ library, build the PyBind interface for it, and then we'll run the test. And it all happens behind the scene without the developer really knowing. So all those things were really major productivity gains. So that was my first encounter with the mono repo. And when I started Semantic, I started with the mono repo from day one. Well, obviously, when you start from day one, you have one repo, but basically all those components of the product were in the same repo. It's open source as well, so you want to centralize things. Obviously, you don't want people to start different repos or whatever. So this product contains a metadata server, basically a Flask server, and a Python SDK, like a wheel, a TypeScript UI, like a React app, if you will, and then a bunch of ML pipelines. And so all of it stays in the same repo, and everything is being guided and piloted through Bazel. And also, we wanted the SDK to support multiple Python versions, namely 3.8, 3.9, and 3.10. And so we all did this via Bazel instead of using like other tools such as Talks and so on. So whether this was a good decision or not to use Bazel for this repo is arguable. I would argue that it was still a good idea. But when you're stuck in some Bazel debugging issue, then you may think that it's a bad idea. But overall, I think the gain was significant. So this is the usual way to do things, when you want to test, run your test, PyTest your test. If you want to build your wheel, you just Python set.py. If you want to test multiple versions with multiple Python versions, you use talks or different virtual environments that may depend on what machine you're on and so on. If you want to build Docker images, Docker build, and so on. This is the usual way that things are being done, and Bazel aims to replace all of those with a single interface, if you will, where all the dependencies are declared as Bazel targets that builds a dependency graph and leverages the code as needed for those tasks. And I'll show you a bit more detail in a minute. So this is Bazel. You can find it, I think, bazel.build or something like that. And so a few things to point out is that it aims to have very granular dependency tracking. So basically each of your Python module is declared as an asset. And so when you run a test, it's only going to rebuild the modules that have actually changed. And so also only the tests for which the code has changed are being executed. So it's supposed to be very fast because it parallelizes across all your CPUs on your machine, and also does a lot of caching. So if your code doesn't change, if some of your modules don't change, their tests are being cached and they're not being rerun. I'll show you a demo in a minute. Also, it supports many different languages, so that's really great when you have a monorepo that has some Python component, maybe some Java, some Go. You can have a very unified tool chain across all those tools, which is extremely practical. And also on the scalability part, by default, Bazel is going to run your build on your local machine, but you can also have a remote build service so that if you have some very powerful machines, for example, when you submit your build, Bazel is going to package your local environment, your local code, ship it to a remote build machine, build there, and give you the results on your local machine. So, I mean, obviously nowadays we have M1 Macs that are super powerful and sometimes more powerful than VMs you can find in the cloud. But when you're trying to build extremely large code bases, that can be quite useful. So yeah, so this is Bazel. So this Bazel is basically an open source version of an internal tool at Google called Blaze. So obviously Google has a monorepo. I've never worked at Google, but I've heard it has a monorepo, meaning like Gmail is in the same repo as YouTube, maybe not YouTube, I don't know. Many Google products, and Bazel is built to support many different languages, and it has its own language so that you can extend it and support even more things. Obviously, this is for experts, but that's good to know. So it's meant to do all those things. So like build and run binaries. So the web server that you're trying to develop, for example, you can run it with Bazel. You can run tests. You can build wheels, Docker images, and so on. It's supposed to make your build extremely reproducible. For example, if you have a failure on your CI server, by running the exact same Bazel command that is being run on the server, you're supposed to be able to reproduce the failure on your local machine. Obviously, there are always moments where, because of network latencies or whatever, you cannot exactly reproduce the failure, but it's supposed to make it much easier to debug things that you see in your CI or in production. Also, it aims to standardize greatly across all the machines by using a method called sandboxing. So basically, when you use Bazel to run your binaries or to run your test, it's going to create a sandbox inside on your machine that is completely isolated from the rest of your file system. So Bazel is actually pretty strict about that. It doesn't access any files that are not declared as dependencies of your build targets, which means that if you forgot to, let's say, link a library or maybe a static asset like a fixture file, something like that, and that this file is not going to end up in CI, for example, you will notice it locally because Bazel will say, I don't know what this file is because it hasn't been declared as a dependency. So that's a great way to standardize. Even your Python interpreter is being built from source in that sandbox environment. It's not using your Python 3 interpreter. It's using something that is being downloaded and built for the particular build that you're running. And as I mentioned, it's very smart about caching. So you can run your entire test suite blindly, and only the tests for which the code has changed, not just the code of the test, but of the dependency, will rerun. So that's very, very efficient. So this was a Hack and Use post. Maybe you can't really see it, but I'm going to read it for you. This was the 2015 Hack and Use post when Bazel was launched, and you get a couple of Googlers here that are telling about how they were delighting to work with Blaze. So for example, this guy saying, working at Google, Blaze is one of the technologies that amazes me the most. Any engineer can build any Google product from source on any machine just by invoking a Blaze command. And it says, I may not want to build Gmail from source, but it's awesome to know that I can. And then the other person says, using Bazel, let me just click this. Using Bazel every day is one of the things that has made me dread ever leaving Google. Fast, reproducible builds are amazing. Once you have used this tool, it is hard to go back. Personally, but anyway. So that gives you a sense of what it is like to work with Bazel. Obviously, it doesn't come without costs in terms of integration time. So I wouldn't recommend necessarily using it without having a bit of expertise or having a build engineer in your company. But it is very powerful and very delightful to use when it works. So how does it work to set up Bazel in your repo? So first you start with a workspace file that you define at the top of your repo. That's where you define all the things that are centralized across your repo. So you import rules for each languages that you use. So like your Python rules, your Go rules, your C++ rules, and so on. You define the Python interpreters that you want to use. So for example, if you want to use different versions, this is where you define them and so on. Then in each directory in your repo, you write a build file. I'm going to show you this in the code base in a minute. So you write a build file in each of your directory where you define build targets. So build targets could be a binary that you want to run, just a script, for example, or the entry point to your web server. It could be a test, like a Python test, for example. It could be building a wheel, building a Docker image. It could be as complex as you want, really. So those are defined in those build files. So you define those builds with rules that are basically provided out of the box by Bazel. So like you have a PyTest rule for Python test, a PyBinary tool for Python binaries, and so on. And you can also write macros, so like a bit more complex logic around your build system, around your build logic. And for that, you use macros. Bazel comes with its own language called Starlark, which is a Python dialect. Not the biggest fan of that personally, but it is still pretty powerful. And so in your build target, this is where you define the dependency graphs between the different modules in your repo. And I'll show you in code how this looks like. And then you invoke, actually this is incorrect, it's supposed to be //build. Then you invoke the target. This is incorrect. It's supposed to be Bazel build //run/test. This is how you invoke the actual build of that target. So it could be Bazel build, Bazel run, or Bazel test, and then the path to your target. And so, as I mentioned, when you invoke this command, it's going to run your target in the hermetic sandbox, meaning that it's somewhat isolated from the rest of your file system, so that you're not missing any dependencies, and it guarantees a high level of reproducibility. So maybe actually before going into that, let me switch into my VS Code if this works. Yeah, okay, good. Is this big enough? Can you guys read? Okay, so this is the workspace file for the schematic repo. So there's a whole bunch of things here. I'm importing some dependencies, and then I am importing the rules Pythons here. So this is where I'm bringing in all the stuff to do some Python things, and then I'm registering here a bunch of tool chains. I'm registering the 3.8 tool chain, 3.9, and 3.10. Don't necessarily try to understand this. It's kind of kind of hard to wrap your head around, but this is to give you a high-level idea of what it looks like. And then you define the different requirements files for each of those versions. I'll show you in a slide later how you do dependency management in terms of external dependencies for requirement files. And so once you have your workspace file, then you can define the build file. So let me bring this is an example of a build file. And here, for example, I have a build target for a particular module. So here, this is the source of module. This is just init. So this is the root of the schematic repo. So obviously, that's why it has many dependencies. These are all the things that I want included in the Python wheel when I build it. And so here, for each Python file, I define a build target, and this is how I define the dependencies between those things. So one of the best practices, I'll talk about best practices later, but is to have one build target per file so that you have a very high level of granularity. And so when you rerun tests, for example, this is how Bazel knows, okay, this file has changed, and all of those tests depend on this particular file, particular module. And so I'm going to rerun all those tests, and I'll give you a demo in a minute. So here it is. I define all my libraries here and dependencies and so on. Let me bring up one for tests, so show how it looks like. Yeah, these are tests. So here, for example, I have a test file, and I call this this rule here to define a test target, and I declare the dependencies and so on. So for example, here I have a whole list of dependencies for this test. If any of those file changes, Bazel knows that they need to rerun this particular test because one of the dependencies have changed. So it's pretty smart about that. Otherwise, all the tests are being cached. So let me give you a quick demo. Here I'm going to run the entire test suite for this repo. I ran it this afternoon, so I haven't changed anything since then, so it should be extremely fast. So there it is, it's starting down now. And so there's about 1,400 targets. So a lot of things are happening, but it should be very fast because everything is going to be cached, hopefully. Yeah, checking cached actions. And yeah, so there's quite a bit of code in this repo, but you're going to see pretty soon a whole list of tests like this that are being cached. And then I'll make one change to a random file, and I'll show you the tests that are getting triggered. So while we wait for this, you can see here that for each target, each test target, I have 3 targets here. One without a suffix, one with a Py310, and one with Py39. This is because we've set up the repo to test with those 3 Python versions. And so for each of those individual targets that I showed in the build file here, behind the scene, there's also an equivalent target for the other Python versions. And we've implemented this with our own custom macro. As you can see here, I'm using this macro here as a custom implementation that we did so that every time I declare a single test, then it's going to duplicate the tests with different Python interpreters so that it tests for all those versions every time. So here by default, you can see, there you go. So the build has completed, everything has been cached, so nothing has been rerun. And so now let me make a change to an arbitrary piece of code. So let me open here on the side, the code base. Where am I gonna make a change? Pretty low level so that it triggers quite a bunch of things here. db.py. This is a pretty low level, so I'm just gonna, add some code here. There we go, and save. And I'm gonna retrigger my build. And so here, automatically, Bazel will like, okay, this file has changed, so I need to rebuild all those tests because this is all those tests depend on this particular db.py file. So this is very practical. It doesn't really run the tests that don't depend on this file. Now, this is going to take a while, obviously, because that's quite a bit of test. As you can see here, there's about 8 tests running in parallel because the machine on which I'm on, I'm connected here to a remote VM as 8 CPUs. But yeah, this is roughly how it works. So yeah, I know this is a lot of information. You know, when you encounter Bazel the first time, like, what the hell is this? But once you get used to it, it actually makes a lot of sense, and it's pretty cool. So going back to the slides. So yeah, as I mentioned, you can build macros that use this Starlark language, which is a version of Python. I think it's a subset of Python to customize your build behavior. For example, as I mentioned, you could write a macro that requires the user to define a single test target and will create under the hood one target for each Python version plus a test coverage target. For example, here I have a single test target defined with the dependencies here, and PyTest test here. This is the macro that we've defined. And as you may be able to see, not sure, it's kind of small. Here we iterate over all the Python versions we want to support, and we create a test target for it. And if I equals 0, we test we build a coverage target for this. Now, obviously, this requires a bit of skills to write this, like learning about Bazel. So it's not really available necessarily for the beginner, but you have some very powerful things that you can do with macros. For example, one of our macros will build a Docker image at runtime, will register this Docker image to a remote container registry, and then we'll execute a script that will submit a ML pipeline to run on a GPU cluster. So pretty extensive suite of actions that are all implemented thanks to a Bazel macro. So for Python, you basically declare in your workspace file, you import the Python rules that are supported by the official Bazel repo, and that gives you access to those 3 basic Python rules to declare a Python library, so just a module essentially, a Python binary, so that's a script that you want to be able to run, and then PyTest to run tests. So this is what comes out of the box, and then you can combine those using the macro language. So you also define all the requirements in a centralized requirements file, and then you freeze it for all your repo. And I'll show you in a minute how this works. And then for each Python module, you define a build target. For each test file, you also define a target, and also for each wheel, you define a target. So this is how you support multiple Python versions. You register one toolchain per version. You see here the Python 3.8, 3.10, and behind here you have 3.10. And then you load the interpreters here. These are the commands to load the different interpreters. And then you expose the targets for pip dependencies. All of those things are going to load your pip dependencies and expose them as Bazel targets so that you can depend on them in your targets, in your build targets. So this is how you do dependencies. So first you define a requirements.in, so not .txt.in, and this is where you keep things fairly loose. So of course you can pin versions for the ones that are important for you to pin, but you can leave the other ones fairly free. And then you run a target that has been provided by Bazel, and this is actually going to freeze all your requirements with exact hashes of each of the dependencies. So this is actually all the dependencies of your repo, not just the direct ones, but all the transitive ones as well. So for example, if here, SQL Alchemy depends on 10 packages, it's all going to end up here. So you have like a source of truth that of each exact versions of all the packages that are used in your repo. And then once you have that, you can add dependencies in your targets in this way. This is the standard way to use PyLibrary. You define the name of the targets, then the source for it, and then the dependencies. This is another module in the same directory, and these are requirements that come from that list over there. Right, so in the beginning I showed you the usual way of doing things, and this is how it looks like in Bazel. So testing, you would do Bazel test and the path to your test target. And then if you want to run a binary, you do Bazel run, the path to your target. Then if you want to build a wheel, Bazel build, and so on. If you want to test with multiple versions, this doesn't come out of the box with Bazel. You have to do a bit of gymnastics, as I showed you. But all this is documented. Also, it's in our code base, which is open source. So if you're interested, you can always look at that. And you can also automate building Docker images with Bazel. So in terms of best practices, first of all, you can look at the best practices that are on the website. The goal is to define your targets in the most granular way possible to leverage parallelism as much as possible and caching as well. If you define a single target for all your code, then every time anything changed, everything is going to be rerun. That kind of defeats the purpose. So that's why you should have one target per Python module, one target per test file. You also should define all the dependencies directly, so nothing transitive. If your Python module depends on those 5 things, so an external third-party library, you should always include it here. And same, each of your dependencies here in terms of internal modules should also be listed here so that there's no hidden dependency. There is no dependency that's included because one of those things depends on something else. So this is a way to maximize this caching mechanism and parallelization. So this is a lot of work, as you can see, using Bazel for Python is a lot of work. So is it worth it? So as you can see, it's a non-negligible amount of boilerplate code to write, like all those Bazel declarations to do, this workspace file, and so on. Especially if you want to support multiple versions, as you saw, you have to declare all the interpreters, you have to import all the tool chains and so on. However, it means that your interpreters are consistent across all your machines. So, for example, back at Cruise or even at my company now at Sematic, nobody has ever said, oh, what minor version of Python 3.8 are you using on your machine? What virtual environments are you using? We don't care because we all use the same. It's all being downloaded and built at runtime by Bazel. So it may seem like a lot of work to set up Bazel, but think about all the times that you were scrambling to fix a dependency issue because of some bug because of some minor Python version, or maybe a difference in version in a dependency. So that's quite a lot of time saved. Also, having a hermetic build is very valuable because it means that the build on your machine is essentially going to run the same as the build on the remote CI machine. Of course, not talking about architecture differences. If you're running on a Mac versus a Linux in CI, these are some differences that are not reflected by Bazel. But this sandboxing is really powerful. So as I mentioned, you can reproduce all your builds and tests across all machines. You have this very granular declaration of the dependency tree, which means that when you run your test, only the test that need to run, which means that you are saving a lot of time. And also it means that you can parallelize things much faster. So yeah, also consistent dependency. I remember at Cruise, before we did the monorepo, we would spend hours, sometimes days, debugging issues because there was a different version of like the request dependency, for example, in one repo versus another. And these are all sort of paper cuts that are really dragging down your productivity. You should not be worrying about this as a developer. So yeah, as I mentioned, very fast builds because of this granular system, and it's parallelized out of the box. So all those things maybe make up for the non-negotiable boilerplate, maybe not. I'll leave it up to you to decide in your particular use case. But in the case of a company like Cruise, it did make a difference. So yeah, no longer do we hear any of those things, what minor version are you using. Those two apps in the same repo have different versions of pandas, and it screws the build. I can't have both pandas version in the CI at the same time. I'm not able to reproduce the failure on my local machine. All those things disappear because of thanks to Bazel. So everything in engineering is about trade-offs. You have some gains and you have also some costs. So when does it make sense to potentially look at Bazel? Or if you have a monorepo with multiple apps and languages, it could make sense. If you have a repo with just a few modules with just one language, one app, maybe not. Maybe you don't get a lot of value there. Also, if you have a large code base that is touched by a lot of different engineers that are making changes all the time to different apps, different languages, it may make sense to use Bazel. I would recommend having access to at least one person that knows Bazel, so like a build engineer or you if you want to really get into it. But if you're a small team of developers, and you want to take a look at it, maybe treat this as like a toy project because it could suck your time. So be careful there. And so if you're also building a prototype, so something that's not going to make it to production, you're just toying around, don't use Bazel, right? Because that's going to be an upfront cost to set it up in your repo, and so don't use it. So yeah, this is just a self-promotion before I end the talk. The company that I started after Cruise called Sematic. It's an open source ML orchestration platform. If you will, it's a replacement for things like Airflow, for those who know that. So this is built based on the learnings that we gathered at Cruise for 4 years. So it's open source, so feel free to check out the repo and give us a star. And all the things that I mentioned today, it's in the repo there. So if you are interested in using Bazel in your own repo, feel free to take a look at what we did there. We also have a Discord channel, so you can always come in there to say hello and ask questions. And lastly, we are about to launch a new product called AirTrain, which is an LLM-focused no-code application to evaluate and fine-tune large language models, which is built on top of Sematic. So we're taking pre-signups now. So if you're interested, take a look at that. Thank you so much. Happy to answer questions now. Yes, so I left Cruise about 1.5 years ago, so I don't remember those things, but it was pretty massive. The build itself was taking about 40 minutes. You had mostly a large amount of C++ code. All the testing and simulation code was also in there. So I don't have numbers. In terms of numbers of developers, I would say probably around 400 developers, I would say, something like that. Yeah. Have you worked with Gazelle before? Oh, actually, Gazelle, we use Gazelle in Bazel, right? I think we use it for to build Docker images. Is that right? I think I'm a yeah, yeah, yeah. Yes. So that's great because it is true that you do spend a lot of time having your Python file on one side, your build file on the other side, making sure that every line matches, especially if you're a little bit, peculiar about those things. You want things to be sorted and everything map one to one. So yeah, that's one pain point. Yeah. So if you forget a dependency, and if it's not included by a transitive dependency, then Bazel is going to tell you, I don't know where this file is, because when Bazel creates the sandbox, it creates soft links to all the dependency files. And so if you forgot one of the modules, it's going to tell you, I can't find module1.py, even though it's on your machine, but the soft link hasn't been created by Bazel. So that forces you to create the dependency. However, if you remove the dependency from your module and forget to remove it from your target, nobody's going to tell you that. So you have to do your own discipline, your own cleanup. So that's another thing to worry about. Yes, exactly. There you go.
That was basically my question. I was going to ask as well. Does that build file look sort of like a old make file? And want the computer to figure that stuff out. So is it they'll do it, and we also take a slightly different approach where we give up the grade by doing full level rather than like for file targets.
Right. Everything is a trade-off. So yeah.
I had one question. Mm-hmm. You had setup.py. There's also pyproject.toml. That
so you don't use any of those with Bazel. You basically have. Let me bring it up.
Everybody tells me when I set up that pie, I'm old school and I should like modern.
I think our wheel target is in this file here. I think down here. Yeah, so this is the wheel target here. So this is the custom macro, but it basically wraps around the basic things. And this is basically you define all the things that you would define in the setup.py. And if I want to build this wheel, I just invoke Bazel build / semantic :wheel, and it's going to basically build the wheel. That's it. There's no setup.py right here. Basically, in the setup.py, you define all those things here. So, the author, the requirements, and so on. All this is already written in here, so you don't need a setup.py. You don't use any of those things here. You only use the build file. We don't have PyProject, right? Yeah. That's right. Yeah, so Scholark is basically all the file here is defined in this language, and then the purpose is to also define logic. So let me show you here. This is the macro for our test target. So I test, and it looks from the outside like a regular rule, but there's actually a lot of logic in here. For example, here we define all the Python versions that we want to support, and then we have a loop here that will define the actual targets for each of those versions. So all this logic here of like concatenating strings and looping over things is implemented in Starlark. However, it's a subset of Python, so there's things you can't really do, but it's useful to do this kind of logic around your build.
Okay, well, thank you.
All right, thank you very much.
Hi, everyone. So I'm Josh. I'm a software engineer here at Sentry, and today I want to talk about our REST API doc tooling journey. So before Sentry, I worked at various small startups, and I've been here for nearly 3 years. And I primarily worked on our backend enterprise APIs, which sort of influences this talk, and now I work on our session replays product. But yes, let's get into it. So how many of you have heard of OpenAPI or Swagger or any of those toolings? Okay, good amount of people, good. But yeah, so basically when you have an HTTP endpoint, you need a way to document it and share it with the world so that way they know how to call it, how to use it, and then there's even tooling where you can give it JSON and it'll spit back out like a client for you to call endpoints and so forth. So on our Sentry website, this is kind of what our API tooling looks like. So you can see this is a post to the project's endpoint. And basically, you want to be able to describe all the parameters, how people can call it, and then give some examples that we have here on the right. But yeah, so kind of the scale of this at Sentry, we have 400 plus APIs, and around 80 of them are documented, which results in about 40,000 lines of OpenAPI JSON. That's a lot. And then we render it all at a Gatsby site at docs.sentry.io/API. So how do you manage this all? And this has been kind of an open question at Sentry for many, many years now, and we've tried out a few different things. And so I'm going to kind of go into the various things we've tried, the pros and cons of them, and where we're at now and how that looks. So kind of as a starting ground, so for Sentry, we're at Python 3.8. We tend to upgrade things kind of slowly. When I first joined, we barely switched from Python 2 to 3 in 2021. And yeah, so we finally now on Django 3, which was quite an accomplishment for our org, and 500,000 lines of Django code. So that was a lot. And we kind of use Django Rest Framework to manage our APIs within Django. Kind of allows for more abstractions, but we don't really use it in the way that we're supposed to. And I'll kind of go into that in a little bit and how that causes issues for API documentation. So our first version of API doc generation was sort of simple, and we actually weren't using OpenAPI at the time. We essentially would spin up our server in a test harness, generate a bunch of dummy data, and then just run a test, iterate through all the endpoints, and take the responses along with the schema of the responses in JSON and turn that into a markdown file. And so the kind of input was a bunch of tests, and output was markdown files. And in 2018, this is what this looked like. And it kind of pulled things from autodoc where it could, but more or less you got a bunch of curl commands and vague ideas of a schema and vague ideas of a response. So it was pretty cool because you actually didn't have to write the schema anywhere, and you didn't have to write any requests response examples. And so there was a lot of automation, but kind of you're sacrificing managing this build process and managing how this thing starts up and how you get it to run, and generating all this dummy data and turning that into something that ends up being kind of a full documentation of the schema. And so the other thing too is you would change things in your code, and then you wouldn't realize it actually changed the documentation in a certain way. And so it's kind of hard to view how your code impacted to the documentation. And so around maybe 2020, we switched to OpenAPI. So unfortunately, we were on such an ancient version of Django that no tooling really worked with what we had. And so we just went ahead and started writing OpenAPI JSON manually for all of our endpoints, which was quite the task, and it took a long time. And you can imagine, 20,000 lines or so was a lot of work for our team to do. And the other issue with just writing it manually, not having it be part of your code, was that basically you had to write tests to validate that the JSON in these examples actually were returned by the endpoints. And so there was kind of a lot of overhead for that. And then essentially when developers would write new endpoints, we would notice that people wouldn't document stuff if it wasn't right in front of them and really easy to do. And so trying to advocate for more API documentation and trying to let more of our external customers use our APIs started to become more and more of a focus for us. And trying to get people to do that was quite difficult because if something's not right in front of a developer, if they don't have to do something to get a PR merged, if they don't have to, people want to optimize and think about as little things as possible. And so part of all this tooling was, okay, we need to make things sort of ergonomic and make things kind of intuitive and make it sort of like a game. It's like, oh, my like thing failed because I didn't do something right, so I have to like go fix it. And so you want to get people on that sort of railing as opposed to like, oh, like I don't know what to do, it's failing, and I don't like this, or oh, I was supposed to document my API. Well, you didn't mention in code review that I needed to do that, and so I didn't do it, right? So like you want to have as many things automated by CI and automated by the computer as possible, and leave the human intervention to a minimum. Kind of get people playing their own internal game is kind of our sort of methodology here. And so basically, we finally got on an old enough new enough Django version where we could start looking at tooling. And there's a good one called DRF Spectacular, and it's a forked version of DRF Yasage, if you've used that before. And so basically, what that allows you to do is do more inline documentation of endpoints, and allows you to parse your entire kind of Python model of all of your endpoints and iterate through and turn each endpoint into OpenAPI JSON. And so this was kind of appealing to us because, you know, we use DRF, we're on this thing. So if we just install this tool, will all the API generation just be done automatically? And can we just, you know, put this out there? Developers don't really have to do anything, and we just get great docs. Is that the case? Not really. And so let's go into that. So basically with DRF, the idea is you have these things called serializers, and serializers represent how your data goes from being in the database, how it gets into the database, and how it gets out of the database, so request and response. And so if you're using a very straightforward implementation, you're using this thing called a model view set, where essentially you define a serializer, and your, in this example, album serializer contains sort of the schema for doing request validation and response, sort of turning that database into the response. And you have very minimal custom implementation, and everything just sort of goes by the spec-defined code. And if we go into what a Sentry endpoint looks like, it basically looks nothing like this. And this is because for various reasons, Sentry has had to not use a lot of this library. And so while we are, you know, using this library kind of by namesake, we're not actually using any of the utilities and ergonomics that the library provides for. And so when we set this up, a lot of it didn't actually work. And so our dream was kind of in question a little bit, and we wondered if it was even worth trying to pursue API docs tooling at all in the current fashion. Yeah, so basically, a lot of this came down to historically at Sentry, we just write a lot of code in our endpoint, and so we don't rely on like big models or kind of abstracted away things. If you want to do something, you just put it right in the endpoint, and yes, that kind of results in more kind of repeated code where you're doing kind of same things in separate endpoints. Historically, that just let us iterate really fast, and also as we scaled, as we became, you know, from a small startup to something that, you know, we got a lot of developers and a lot of people hitting our APIs, a lot of people using our UI. Speed became an important thing, and then eventually we had to migrate off of Django and Postgres for a lot of our data and do kind of a more, we use ClickHouse a lot, we use a lot of OLAP databases, and then some other databases where essentially we don't even have Django models for a lot of the data that we're returning. So how are we supposed to use this Django Rest Framework and all this auto-docking if we don't even use Django models for our data? And so this has kind of put us in a pickle because if we don't have a defined schema, then the whole notion of API documentation goes out the window. And a couple other notes here. So, and this was even early on before we switched off of Postgres for a lot of our data. DRF serializers are really slow at, funny enough, serialization. And so we had to switch off of them a long time ago. And I can kind of talk about that a little bit because I thought it was very interesting, as I wanted I sort of considered, okay, like let's get all of us to move back to these serializers. But basically, here's what a Django Rest Framework serializer looks like. You can see, you go ahead and define all of your fields, and you can call things booleans, integers, date time, and the kind of keys on the left sort of say, you know, what the data, you know, what's the name of the data and what's the shape of it. But basically, a fast serializer, something that's really simple, looks like this. So essentially, you take in a model and you just return a straight up Python dictionary of what it needs to be. And it kind of turns out that, like, if you look at this bottom here, the serialized user, compared to the other ones, we're talking orders of magnitude in terms of speed. And so very early on, we sort of realized we had to do that. And at Sentry, we just never switched off of that because trying to get something with a more defined schema has been really hard. So yeah, so we're kind of in this hard thing where we, serialize data and there's no schema at all for it. So we're in a pretty tough spot. But yeah, so we return a dictionary. So what if, so looking at this is an example serializer of ours. It's just like the kind of toy example from the previous example. We return a dictionary and we do a couple of things in there, but more or less, right now it's a dictionary of type string any for the value. But okay, what if we type the dictionary? What does that look like? Okay, so we can use typedict, and if you just specify a return value of a typedict in the serialize function, that's pretty good. Okay, we're starting to work with something, and you can see how this could start to work. We use Python types, and maybe somehow we can turn that into OpenAPI JSON. So from there, we had to figure out if we could hook this into our DRF Spectacular documentation framework, and it turns out we could. They have a method, basically, you define the class of your serializer and a way to map the serializer into OpenAPI formats, and we were able to use a lot of the internal libraries and basically use this getTypeInt function to turn Python type into OpenAPI JSON format. And what that looks like is basically, say for a Python string, that's essentially just a JSON string. And so there's a few different, there's not too much ambiguity around what a Python type is in OpenAPI JSON. So that this worked reasonably well. So yeah, so we pretty much had to write this, and basically we were kind of off to the races in terms of, okay, we have a proof of concept, but what do we actually need to do to get this working in production? And I'll give a quick demo of what this looks like in our code and kind of how that gets turned into JSON. And so, I'm sharing a window. Let me share my screen. So yeah, so for each endpoint, we just have to define a response serializer. And so basically, if we go in here, we go and look at this replays detailed response, and we can see that essentially for all the fields, we give them Python types, and this is validated by MyPy, so we know that they're correct. And when we run our docs build, it turns this into this kind of JSON that before we had to write manually, and so the sort of core thesis there was that one, writing Python types was slightly more pleasant than writing this OpenAPI JSON, and two, if it was validated by our type checker, then we know that's probably a little bit more correct than it not being validated by a type checker and having to be validated manually with a test that someone would have to write sort of correctly. And so a few other different things. It can do things like look at the doc string of the function and put that on the web page. And what this ends up looking like finally is this page where we take this JSON and render it in kind of a pretty way. But yeah, and so some pretty cool thing, and like this sort of may seem like table stakes, but to us it was like kind of a big deal. But like, for example, you have this enum field, and before you'd have to copy paste this all into JSON, and now basically this is all automated, and so you give the things you want, and in addition to things like permissions and a lot of other things where there's just a lot less manual work that you have to do to document something. So yeah, and so really it's a lot less manual work. Examples can live alongside code. So in our example here, we just specify an example, and if we go look at it, so when someone makes a PR, you can kind of look and see if the example that they're giving is sort of in the spirit of what a person would reasonably send to this endpoint, or what a reasonable response would be. And so there's kind of a shift when you do this of thinking like the documentation is part of the code and it is part of the quality of what someone's producing. And so you can start to shift that over. And I think that when you're a developer, especially a developer tool and a company that is kind of going towards an API first world, this is just as important as the code that someone's producing. So some other pros, if you're using MyPy or one of the other Python type checkers, you have a pretty good idea that they're correct and that your JSON is going to be good. And the framework is pretty modular to where if there's something that's just really crazy and you can't represent it with Python types, you can fall back to writing the JSON manually, which you can do. And so it's nice to have that kind of fallback mechanism, especially as we had to transition, nearly 100 APIs over. But yeah, so let's talk about some problems that was really interesting to run into during this implementation and kind of some ways around them. So a lot of them were really due to Python typing, unfortunately. So basically, we had this a little bit in our code base, but during the documentation of our serializers, we had to kind of put this everywhere. Basically, if you have two modules that kind of depend on each other, and with type checking, it's sort of ends up being where that's way more common, at least in our case, we had to put all of these imports around this if type checking variable. And so if you go look at code, it just looks, it's very weird and it's sort of counterintuitive. And anytime a new developer comes to Python, it's trying to explain to a new grad who's never used Python before, like what's going on here is just like kind of an insane thing to do. But yeah, so thinking back to our documentation generation, the whole purpose of this variable is that we don't import these variables at runtime. We only want to import them when we're type checking. But unfortunately, our API doc generation actually runs at runtime, not during type checking. And so all of a sudden, this variable isn't very useful because we need those types and they have to be at runtime. So how do we get around that? So basically, writing the most cursed Python code you can imagine. So let's go. Basically, we're going to try to resolve the type hint, and if we get this name error, we're going to go ahead and just reload the module with that variable enabled, and we'll try again. Yeah, and so basically what we're going to do, this is the reload module function. We're only going to do it if this environment variable is set to true. If it's false, you can't do that. But yeah, so we're going to set type checking to true, and we're going to try re-importing the module again. And as it turns out, this actually works. No problem. So yeah, yeah, more foot guns. Yeah, I mean, MyPy is pretty slow on our code base. I think really what it comes down to is, one, we have a lot of errors still. Our code isn't 100% type safe. And so when a MyPy error happens, it gets really slow because it kind of has to recompute a lot of its dependency graph. And then also, basically, the way the Sentry's import graph is not good. And so when you change one file, usually you're reevaluating a lot of the code base to type check something. So that's not good, but there's a pretty big effort to kind of make this better. And so I think that as time goes on, it won't be 18 seconds. Hopefully it's something like 1 second or 2 seconds. So some more foot guns. These Python type dicts are a little awkward, and it's because in the current version of Python we're on, there isn't a good way to specify what optional versus required keys are, as opposed to you can say a value is optional, but to say that a key is optional actually isn't possible in this version. So you're gonna have to do this thing where you set total equal to false, and that's where your optional ones are, and then you inherit it, and then you have the things that are actually required. Thankfully in 3.11, and we'll get to this probably in like a few years or something, but there's now this not required annotation that you could put around a variable, and so that lets you make a key not required, which is super helpful. Some other things, if you notice, we're not using the type dict syntax in the other example. We have to use this like weird dictionary / string thing. And if you notice, we have to do this because look at this third variable, count. So this isn't a valid Python variable name because it looks like a method call, but in our API response, we have count parenthesis close parenthesis to represent, that's a function. And so for a lot of some of our endpoints, basically you can't use this normal type dict syntax and have to use this kind of wonky looking one because, and it also goes the same for some reserved keywords. And yeah, so that's kind of annoying. And then, yeah, and this is something I think TypeScript does a little bit better than Python types, but essentially defining nested dictionaries is a little annoying because you can't sort of define them inline. You have to define them sort of one by one and then inject them into the response here. And so it makes it slightly annoying to read, but I think it's not the worst thing in the world. Yeah, so limitations. So it's still not perfect, but yeah, so polymorphic responses are still a pretty big issue, but hopefully and this really hasn't been the case, but if you do have an API that essentially based on a Boolean returns totally different values than the other one, it makes it sort of impossible to kind of type in a sane way because trying to say things things in the object are optional versus non-optional is really hard to do in a ergonomic way. And then, yeah, there's no really good way to mark deprecated fields with Python types at the moment. So we kind of have to do a decorator or annotate it in some way that's not native to typing. There are a bunch of, there are a lot of PEPs, PEPs that are kind of looking at in 3.11, 3.12, and forward that kind of allow you to define more custom annotation type things that we may be able to leverage for this. But yeah, at the moment, that's kind of a limitation. And then there's no good way to add descriptions to response parameters at the moment. We have to would have to annotate with decorators or something, but hasn't been a big problem for us. No one's been like, oh, like we don't know. Like usually the request parameters are more interesting because that's what the person needs to provide, and people usually know what the response parameters are. But basically, there was this PEP from 20 years ago that I thought was really cool, and I wish that they would have accepted it. But basically, for Python methods and classes, there's a docstring runtime introspection method. But you can't, if you do this for this class variable, this does not work. You can't do like c.a.docstring. That's not a thing. So that's unfortunate. I wish it was a thing, but you know, what are you going to do? Yeah, so if we want to do that, we'd have to do some kind of AST parsing in order to get inline descriptions. But for now, I think doing a decorator is just fine. So yeah, so kind of looking forward, though, at some pretty cool stuff we can do with our code base. And I think this is an interesting lesson kind of for me. And I think is, you know, I'll definitely take this away for future organizations, is that you can enforce a lot of things in your code and in CI, things that aren't related to the correctness of your code. And maybe that's a big idea, maybe it's not. But for example, we now have this code that we've introduced where essentially, if you write a new API endpoint, you have to define that, you know, some team that you're on owns it. And so basically, as Sentry, you know, expands, sort of changes, new teams get formed, and so forth. There's essentially this problem of like, okay, it's 3 years ago this endpoint was written. It's still used by a lot of people, but it hasn't been touched since then. So like, who's in charge of it? And so this kind of became a thing. And so now when people write new endpoints, you need to say, okay, this team belongs to this. And so there's kind of a kind of attributable thing that you can give to different parts of your team and parts of your organization. So another cool thing, we make people add descriptions to everything. So if people define a parameter and they don't say what it does, well then their CI gets rejected. So so yeah, so you can do a lot of, and the thing that I found interesting is that no one got super upset by this, because this is the type of thing where you make a PR and we don't have a great build system where it can automatically detect what builds change and so forth. So you kind of don't figure this out until you get into the CI stage. But this test runs kind of on the quicker side, so if it fail in 30 seconds and people know what to do and come back and they get a helpful error message. And so from there, they can kind of go along the path of like, okay, I've got this PR and it mostly does what I need to do. Now I just have to like fix it up and just have to follow the build errors and it'll tell me what to do to get everything working. So I thought this was a, I don't know, kind of like a mind-blowing thing, because you can start to enforce things that aren't correctness in CI. Yeah, so that's the talk. Open for questions here.
Questions? You showed how you force endpoint as a didn't show how.
Yeah, totally. And so I think that there's kind of two stages to this, and I think one is, and so we've kind of gone back and forth on this versus like using decorators versus making things sort of things you have to define on the class of the endpoint. I think that sort of in my experience, I'm very anti-decorator for these types of things now, because the thing about decorators is that it's hard to know that they're there. Whereas if it's kind of a required class variable or method, it's sort of more ergonomic in that way. But basically, to establish an owner, and does endpoint have an owner actually? No, that's a good point. Yeah, so and that's a newer thing that we added. But if we look at like to define an owner, you essentially say this, and we kind of went back and forth on if this should just be code owners, but I think we decided that code owners sometimes is a little less precise than doing something like this. Yeah. Yeah, and I think that basically the library we use allows you to use this extend schema decorator and essentially supply in whatever whatever you want there. But yeah, I think in an ideal world, we would move the stuff out of the decorator and have this be like, okay, if your method doesn't define an operation ID, then just fail it. Whereas right now, I think the default operation ID, it'll just take like a like the class name plus like underscore get, which is like not what we want because this operation ID ends up actually being what the operation ID ends up being what is listed here. And so, yeah.
Have you guys looked at all as opposed to just type fix?
So I think we're kind of like slower on these types of things just because we have like so much like code and especially code that like that does its job and we just, don't want to like go around upgrading stuff. But I'm curious what you think of it and how you think it could help in this situation.
I'm a pretty big fan. A lot of the stuff that you talked about our shortcomings with the tech fix is supported by Python. So they have this field operator where, so for example, like description, basically rather than your traditional just say like thing is a field, type in, and here's it. So if you take the best example of it, if you take a look at API docs, because they leverage Pydantic heavily. That's their version of serializers, so it's entirely off of. We're also on Django. We're still using serializers, but we have other parts back where we use Pydantic a lot for data and that stuff. We have some like
Totally. Yeah, and I feel like Python is kind of in the I think we're at the point in the company where like I think we're pretty much gonna ride or die with Python. I don't think we're ever gonna rewrite to Java or something. So like I think trying to insert these types of safety systems is like kind of it's definitely an art and a kind of you have to be very, very clever. And so looking at Pydantic I think is definitely interesting. And there's a lot of, even with things like celery and stuff like that, there's just so many parts where there's just no schema right now that we could really use something like that.
Yeah, and Pydantic, one of the other things that I like is if you have types that are not just immediately JSON serialized, but feasibly, or I think like if you have a native date time option, it's all like the right times up,
Right.
Date time fail.
Yeah, yeah.
Pydantic is a little bit smarter. It knows like date time types, like you can kind of give it hints on like here's how you actually serialize this type. Pydantic types, embedded within Pydantic types.
Yeah, totally.
And I think it would actually you can fairly gracefully not like the schema is civil.
Totally. No, that's awesome. Thank you.
Yeah, another question?
Yeah, totally. Yeah, and I think that I think we're still in the early stages of like, okay, like Sentry was just like this thing, and all of a sudden, boom, we have like 1,000 endpoints, and like now all of a sudden, like half of them we're not really sure what team to give them. But I think the idea is eventually, yes, leverage this along with custom tooling to create SLAs for each team, and if their endpoints having issues, then to sort of notify them. Right now, it's very much like a little bit of the Wild West, which is not where you want to be with some of that stuff. But I think using I think that's particularly also why we chose doing something like this instead of coners, because you can include a lot more metadata in this kind of file, in this kind of variable with like, okay, like here's the team, like here's what Slack channel they report to, and like, you know, start adding things like that to where you can kind of get into a more of a world of that. And but yeah, that developer operations side of it, it's very I'm excited for our future and having a lot more of that automated. Thank you.
I've got a question, and I don't know if it's really a Google thing or a style thing, but I'm a real dry advocate. Don't repeat yourself.
Mm-hmm.
And I see lots of strings here, and I personally use like how you're on the version like enumerations.
Mm-hmm.
Spring them, they spring enumeration. Is that something that go to that would help you with your typing situation? Just raw strings, spring them.
Yeah, I think yeah, I would say at Sentry our code base is more duct tape than dry, and I think that and I think there's been and there's sort of pros and cons to that, but I definitely agree that a lot of what this ends up looking like is not the most elegant and pretty. I think that using enum values and honestly, a lot of this stuff could be way more dry. It's just a matter of spending the time and investing in the tooling to do it. But I agree. I think it's not the prettiest thing in the world.
Any other questions?
Yeah, and so basically what that usually looks like is you print out, like, I think that is one thing that I'm not quite sure how to get that workflow down, but basically, for example, this endpoint, it pretty much just comes from either you run a test and print out the response and throw it in there, or you're hitting it in your browser and just copy pasting it, and then maybe modifying some things to remove PII or you know, I guess we have Lionel Richie in here. Yeah, maybe remove PII. Hopefully. Yeah, no, great question though. I think and I imagine I'm curious to try out Fast API and see what that looks like in a more modern world and how they do that type of thing. Yeah, I think directionally that's where I want to go. I think that I think one initiative, and hopefully this gets done sometime, is to actually have kind of the way developer docs work at Sentry right now is basically we have this separate repo where things go in, and if teams want to write things about, you know, for example, we have a lot about database migrations or our serializers here. But I think sort of my philosophy on this is very much like, I think the documentation needs to be as close to the code as possible, because thinking if someone's going to go clone a separate repo, get it running, open it up, go write their own stuff, versus all the code is there in a markdown file and the top level of a folder, you have to do, I think you have to do that. So I think eventually we'll probably get that integrated, but I think for now, the Python types themselves, along with the code ID integration, ends up helping quite a bit, in theory at least.
All right, well, thanks, Josh.
Thank you.